given that the summation of series 0 to infinity, okay, from x to the negative x minus 3 to the n converges to x equals 5, which of the following must be true? Okay. So we're given a series, which is just a whole bunch of numbers added together. And we're given some mystery coefficient, a of n. So the idea here then is we're told that we have 3. So we know that it's centered at 3. So this is our, not timeline, but number line. And we have 5, we know it converges at. So, this is interesting. So we're told it converges at 5, but we don't know if it converges out here as well. So let's say 6 converges question mark. So the idea is we don't know anything about where it diverges because it only tells us where it converges. And your first thought process might be like, well, there's obviously a radius of convergence of 2 here. So it converges between 1 and 5, but it diverges everywhere else. It's like, well, maybe. But beyond that, we don't know what this an coefficient is. This an coefficient could be something so that it always converges. It could be like 1 over x to the n type thing. Or 1 over x to the 2n. So that an could cause it to converge more. So we don't know that it could converge. So this must be true. So it might actually converge to 7, but we don't know. It might, so we have, let's see, negative 1, 1, 2. So it might, so we have 1 here. The first thought process is, all right, we have radius of 2 here, so we should probably have a radius of 2 here, and it'll converge for both of them. And so we can pretty much assume, that's a terrible way of saying, we can assume that it converges from 1 to 5. Well, we know that it converges at 5. And so it's also going to converge at 1 because of the 2 radius of convergence. But we don't know if it's actually going to converge at 1. 1 may or may not be included. And the reason for that is if you have the right sort of setup with a coefficient an, what you could get here is you have basically a geometric series here that is converging. But you might get the sort of thing where you get an alternating series. So an alternating series is where you have something negative 1 to the n. And what happens is for the alternating series, as long as the limit as n approaches infinity is 0, as long as it goes towards 0, and it alternates negative 1 to the n, then it'll still converge as well. I know that seems a little abstract. The classic example here is n equals 1, infinity, 1 over n. Diverges, right? Well, if you do something like this, now it converges by the alternating series test. So you can't actually guarantee that 1 will converge. But then you can't guarantee that 1 will diverge either. So that one's out, that one's out. You don't know about negative 1 because just because 5 converges doesn't mean that 6, 7, 8 doesn't. We know that the radius of convergence, the minimum of the radius of convergence is 2 because 5 and 3. But the radius of convergence could actually be much larger. We just don't know it. So we don't know that anything about divergence. So we don't know if it converges at 7. It could. And all we're left with is 2. So, yes, we can guarantee that it converges at 2, but that's about it. And this could be more than 2. This could be 1 point, or I guess less than. This could be 1.5. This could be 1.25. The idea here is, all we know from this radius of convergence is it converges at 5. It's a radius of convergence of 2 because 5 minus 3 is 2. And this is a geometric series. And we know that 1 will be involved. So, because 3 minus 2 is 1. But we don't know if it'll actually converge or diverge at 1, because there's still the possibility of the alternating series test, which is left ambiguous about. So this is actually a pretty good question. There's a lot of data in here, and it's good to go over the type of question once, because if you came across this question just out of the blue, it could be really easy to throw you for a loop. So the idea here is you're doing a geometric series, so you're looking for radius of convergence, but then the alternating series test is what you kind of have to watch out for. And so converges at x equals 2 will be the only one of these which is true.